So we're going to continue looking at average rate of change. These are the warm-ups for my class, so if you want to work on them from yesterday's lesson, I think that'd be the best way to approach it. Pause the video and then check your answers when you're done. So the first function situation that we have here involves what kinds of things, you guys? Because I'm going to ask us for context on our answers. What do we got going on in this one?
It's the population, right?
Population of rabbits over a certain number of days, right? So different stuff is happening with this rabbits. I'm going to ask you to speculate about what's actually happening when we get done with our average rates of change. So first we're supposed to find the average rate of change, or the average slope between 1 and 12. So we find x values or y values and put those on top. Y values, right? Or f of x values in this case. So let's see, y values, what do we have? At 12 we have 10, so that's what you should have first. At 1 we have 3, so that's what you should have second. If you put 3 and 10 in the other order, that's still okay. I think you should just get in the habit of doing the last one first, but it really doesn't matter too much, okay? As long as on the bottom you do it in the same direction. So I went 10, 10 came from which x? 12, and 1 came from which x? 3. If you did it the other way, you have to make sure you do it the other way on the bottom.
It's 1.
So,
Because 3 is the y.
yeah, we should have x's on the bottom. There we go. Okay. 1 produced 3, 12 produced 10. Okay, so then you just simplify. So what do we have on top? Minus 7 over 11. So there you go.
Why is it negative on the top?
Oh, I don't know. 7 over 11. The rabbit population isn't decreasing on that first interval, is it? Between 1 and 10? No. Between 10 and 12? Yeah, but between 1 and 12, 3 to 10 is going up, so we should have a positive number of rabbits, right? So we're going to write a couple of these in context. Let's get 15 to 19 done first. So now we're looking at the interval from 15 days to 19 days. So 19, the y value is 18 rabbits. 15, the y value is 22 rabbits. So you should get negative 4 over 4, which is negative 1. Yeah? Okay, what's key here? So I'm going to give you guys time to fix some of your answers on that first day's assignment in a second, is that you put these in context. You should definitely, absolutely have to be able to understand what this actually means, besides just putting the numbers in the right spots. This means the average rate of change of rabbits for so many days. So this says between days 1 and 12, rabbits did what? Increased or decreased?
Increased.
Gained, something like that. Any of those words are fine. Increased. And this number specifies how much that increase is. That's what you're doing here. They increased by 7 rabbits per 11 days. Notice, you shouldn't be having trouble interpreting this. This came from the top, which is y values, which is rabbit values. This came from the bottom, which is x values, which is day values. They're right there. Okay? So that's how you interpret it. If we wanted to interpret this one, we'd say between 15 and 19 days, we lost 1 rabbit each day. Does that make sense? So that's the same way you'd say that one. So then this last couple questions are on what interval is the average rate of change a specific value. So where did you guys think the average rate of change was 0? Where did we not gain or lose any rabbits? What time interval? Ms. Barnes?
19.
Where? 10 to 19? You guys agree? Between 10 and 19, the population stays flat, right? At 18. Yep. So we'd say the time interval from 10 to 19. Anywhere else? So there could be multiple spots on your next worksheet. There's going to be some problems where there's multiple answers, and you've got to get all of them. I think that's it for this one though, right? One interval is the average rate of change -4. Where do the rabbits go down 4 rabbits each day?
Probably
10 and 12. You make the average rate of change between 10 and 12. Here's the fast way to do it. What's the y value change there? 8. Positive or negative?
Oh, no, that's negative.
You lose 8 rabbits, right? How long did that take?
2 days.
2 days. This is just doing it the fast way, right? What is that?
-4.
There you go. Now, is there another spot like that on here? Let's see. There might be. Here to here is gaining 12 for 3 days. That's gaining 4 rabbits every day. That was close. Here to here is losing 4 rabbits in 4 days. That's the one we did right here, so no. I don't think there's any other spot in there that's going to happen. So that's it. That's that one. So just a little context before we leave this situation. What could be happening? Can you guys explain what might be happening here? Like between day 1 and day 10, what's happening?
It's gaining.
So what could explain that? How do we get more rabbits? 'Cause this is what you guys had more trouble on your exam, was like actually explaining stuff. So like, how could you get more rabbits between day 1 and day 10? Oh, come on, be a little creative here. They could like reproduce,
Oh, is that like?
or you could like buy some more rabbits, or you know, different things like that, right? Then between day 10 and 12, like something happened.
Well, a fox came through and ate them all.
But there you go. Not all, well, ate them all?
No, only like 8 of them.
Okay, cool. Or
Predator increase.
some kind of predator increase happened, like could be a fox, or we decided to go sell some of them to somebody else or something like that, right? Then we waited for them to reproduce a little bit more, or we bought some more, and then that fox came back because he just had too much fun with rabbits the first time, right?
Yeah.
I'm just saying, like, give a little context, okay? So let's do one that instead of using a table, uses a function. That's more important as we go on in algebra. So this is a kind of function that we haven't studied yet. We're going to be looking at it a lot next semester. That doesn't matter. You should still be able to do the average rate of change for any function that exists. So average rate of change, I need the y values, I need the x values. So I need to figure out the y values first. So on some of these I'm going to show my work, and on some of these I'm just going to use the calculator. You guys need to be able to do it either way. So let's get the y values for function j of x. The first y value I need is when I put in 4. The next y value for that same problem is when I put in -2. So let's see, maybe we won't need our calculator. So if I drop 4 into the function, I'm going to get -3 times that 4 squared minus 9 times that 4 plus 30. So let's try to do that one without using our calculator too much. So that's -3 times 16. 9 times 4 is 36. That's -48 minus 36 plus 30. And I'm getting some pretty big numbers. So you can go to your calculator here if you want. It's fine with me. I'm going to do it like this though. That's minus 6. -54 is the first y value that I need. Okay, that's stuff you guys should be able to do. I did it quickly. Might take you a little more time. You should be able to do it. Let's do the next one in our calculator. So I also need to compute j of -2. So I'm going to do that with my calculator this time. So here we go. -3 times -2 squared minus 9 times -2. There we go. What was it, plus 30? Okay, so my calculator says that when I put -2 into j, I get 36. I can confirm that with the same work. Okay, you guys should be able to do it either way. All right, so what goes on the bottom here?
It's -4 or 4. That's just 4. Yeah, and then minus.
Minus a -2. You got an extra minus. Nice. Okay. So on the top, we're going to have negative and negative. That's going to be a negative number. We might need our calculator. You can go to it. What is it? Nice. And then down here, I always like to just do this just to show a little work. So this is negative 90 over 6. You could leave that like that. You could also reduce it. You could go 90 divided by 6 is 15. Negative 15 in this case. So, how would you put this in context? I don't have a situation with rabbits or whatever on this one, but I could say the average slope or the average rate of change on the interval negative 2 to 4 is negative 15. In other words, every 1 unit I move forward, I go down 15 units. That's the idea here. Okay? So, I'm going to do this guy now. So, if we put negative 1 in, let's do that one. By hand, I'll switch colors here. So here we go. J of negative 1. Order of operations says exponents come first. Negative squared is positive. Negative times negative is positive. So I have negative 3 plus 9 plus 30. That's 39 minus 3 is 36. So 36 comes first. Put negative 3 in. We'll just use our calculator on that one just to mix it up and get done quicker. I'm going to go negative 3 times... Oh, I'm going to put negative 3 in as well. Minus 9 times negative 3 plus 30. So I get 30 out when I put negative 3 in. What goes underneath 36? What produced it?
Negative 1 minus negative 3.
Negative 1 produced that. Negative 3 produced that. And there's always an extra minus because of the word change in the average rate of change. Change is subtraction. Right? So this is 6, nice on top. And then down here we have negative 1 plus 3, which is just 2. So that average rate of change is 3. So on the interval negative 3 to negative 1, the average rate of change is going up 3 units for every unit we go over. And one last one. So I'm going to do 2 on this one. So I'll do J of 2. It's going to be negative 3 times that 2 squared minus 9 times 2 plus 30. So that's negative 3 times 4 minus 18 plus 30. Negative 12 minus 18 plus 30. Ooh! Negative 30 plus 30. That's 0. Sweet deal. I think I cooked this problem up to work out like this. If we put if we put negative 5 in, I'm going to use my calculator's fanciness here. If you don't want to type that whole statement in again, it's already in there pretty much, right? There's all kinds of ways to shortcut and make your life easier. You hit second entry, it pops up the same thing. And all I really need to do is change negative 3 to negative 5, right? I need to change it right here to negative 5 and right here. Nice! So when we put negative 5 in, we also get 0 out. This 0 came from 2. This 0 came from negative 5. Change is minus. So this is nothing over 7, which is still nothing. In other words, the average rate of change if we graphed this data, or graphed this function, I should say, would be flat. The slope would be 0. We've seen horizontal lines that have a 0 slope several times now. Okay. So there's a couple more examples of average rate of change. When you're working on your assignment, just make sure if there's a situation with context, like temperature and babies or whatever, put it in context. See you next time.